video, I'll be going over the back side of the Math 2 Unit 2 test review. So number 7 asks, a class of 30 students were surveyed on their favorite fast food restaurant. The results are in the Venn diagram below, and you're asked different probabilities. So you've got a three-way Venn diagram here with lots of information. So let's talk first about what everything represents. This 30 here represents the total surveyed. So this is the total surveyed, meaning in all of our probabilities, this should be the denominator. So if you like, all these probabilities that you're going to find, please go ahead and put 30 as your denominator. At least you'll have that part right. So 30 is the total surveyed. You are next asked, what is the probability that someone only likes Bojangles? So let's be clear. This number 4 represents Bo's only. This here, number 5, represents Chick-fil-A only. This 2 represents Zaxby's only. 8 represents those that like all 3. Okay? So if I am asked the probability of a student only liking Bojangles, then I'm going to go right here to only Bojangles and choose 4. So 4 over 30. B, what is the probability that someone likes only one restaurant? Well, these 4 only like Bojangles. That's one restaurant. These 5 only like Chick-fil-A. These 2 only like Zaxby's. So I would need to combine the 2, the 5, and the 4. The 2 from Zaxby's, the 5 from Chick-fil-A, and the 4 from Bojangles only. That makes a total of 11, so 11 out of 30. Next, what is the probability they like none of the 3? That's what this 2 represents. Those that like none. They didn't like Zaxby's, Chick-fil-A, or Bojangles. Something is wrong with them. So the probability of not liking none of those is 2 out of 30. Next, you are asked, what is the probability that someone likes Chick-fil-A or Zaxby's? Think about what this symbol means. It means to unite. Union, unite. That means we need to choose all those from Chick-fil-A, all of these, and we're going to unite them with all of Zaxby's. All of these. So that means I need to total up all of these numbers here. So I'm going to add 2 plus 4 plus 5 plus 2 plus 8 plus 3 all together. And when I do that, I get 24 out of 30 that like Chick-fil-A or Zaxby's. So I'm going to highlight this in green so you'll be clear that what I did in green matches problem D. For E, it says, what is the probability that a student likes Zaxby's and Bojangles? This is an intersection. Intersection, remember, in common. So I'm going to pick a different color. Zaxby's and Bojangles. The intersection, remember the intersection on a Venn diagram is where 2 circles overlap, everything in the area where they overlap. So these overlap here where I have 8 and 2. So I'm going to combine the 8 and 2 to get a probability of 10 over 30. 10 out of 30. Next, I am asked, what is the probability that a student likes all 3? Well, that's these 8 here in the middle that like all 3. So that is 8 out of 30. So next, moving on from Venn diagrams, it says each of the numbers from 1 to 21 is written on a card and placed in a box. So I'm going to write out all the numbers from 1 to 21. And you should do the same. Everyone should do the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I didn't leave any of them out. So now we are asked, if 1 is drawn at random, what is the probability that a number is a multiple of 3 or a multiple of 7? So I'm going to highlight multiple of 3 in one color, and I'm going to highlight all the numbers that are multiples of 3. I have 3, 6, 9, 12, 15, 18, and 21. They're all multiples of 3. Then I'm going to take my multiples of 7 and highlight them in a different color, in orange. So those are 7, 14, and 21. So that got double highlighted, didn't it? So think about what OR means. OR is a union, so that means I need to combine or unite all of these elements. So if I were to unite them all and I'm asked the probability, how many do I have? What is the desired outcome? It is any number that is a multiple of 3 or a multiple of 7. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers that are multiples of 3 or multiples of 7 out of how many different numbers? 21. So that's my answer, 9 out of 21. Next, it says if you are drawing one card from a standard fair deck of cards, calculate the following probabilities. So we have to remember everything about a deck of cards. We need to know that there are 52 cards total. So if we know that, and I'm answering probability of cards here in this section, I'm going to make sure my denominator is 52 for all of them. 52. They are my total possible outcomes when I draw one card. So what is the probability of drawing a 7? So if I draw a 7, there are 4 of those in a deck, so my probability is 4 out of 52. Next, for probability of a heart, remember that there are 13 hearts, 13 clubs, 13 spades, and 13 diamonds. So the probability of drawing a heart is 13 out of 52. Next, if I am asked the probability of drawing a spade or a club, this is what you need to consider. I'm picking one card, so it is one event, but you have to decide, is it mutually inclusive or mutually exclusive? Remember, events or outcomes that are mutually inclusive means they have more than one characteristic at the same time. Mutually exclusive means they cannot be that same card at the same time. So you need to ask yourself, can a card be both a spade and a club at the same time? No. Therefore, this is mutually exclusive. I need you to remember that when events are mutually inclusive or mutually exclusive, you add. If it is mutually inclusive, you will add, then subtract. So what am I going to add together? Well, how many spades are in a deck? 13 out of 52. Plus, how many clubs are in a deck? 13 out of 52. When I add them together, I get 26 out of 52, which should make sense because half the deck are spades or clubs, which would be 26 out of 52. But make sure you are showing your math. We need to see it. On part D, you are asked, what is the probability of a red or a 5? Well, can a card be both red and 5 at the same time? Yes. In fact, the red cards are hearts and diamonds. I could have a 5 of diamonds and a 5 of hearts. So, 5 of hearts, 5 of diamonds. That makes this event mutually inclusive, which means I will first add, then I will subtract. So what are we going to add, then subtract? Well, how many reds are in the deck? 26. How many 5s are in the deck? 4. How many are red 5s? 2. So I need to subtract 2 out of 52. 26 plus 4 is 30. 30 subtract 2 is 28. Next, you are asked, what is the probability of getting an ace or a face card? So again, decide if it is mutually inclusive or exclusive. So can I have a card that is both an ace and a face card at the same time? No. So these are mutually exclusive, so all I have to do is add the probability of each. The probability of getting an ace is 4 out of 52. The probability of getting a face card is 12 out of 52. Add your numerators and we get 16 out of 52. Next for F, can a card be both a spade or a queen at the same time? Yes. This is again mutually inclusive because we can have a queen of spades. So, what is the probability of a spade? 13. What is out of 52? What is the probability of drawing a queen? 4 out of 52. How many are queens of spades? 1 out of 52. So 13 plus 4 is 17, minus 1 is 16. So 16 out of 52. Flip your page. Or look to the right. I'm sorry, I haven't printed on separate pages. So next it says, you are drawing 2 cards with replacement. So this here deals with whether events are independent or dependent. First thing I need you to recognize, you are drawing 2 cards. Therefore, you have multiple events, and when you have multiple events, you multiply. So we are going to multiply 2 fractions together to get our answers. We are replacing the card, which means that the outcome of the second draw has nothing to do with the outcome of the first draw. Therefore, these events are independent and my denominator will remain the same. So since that is the case, I can go ahead and make my denominators 52. So I'm going to have 2 events where my denominators are 52. For my numerator here, the probability of drawing a spade is 13 out of 52. The probability of drawing a black card is 26 out of 52. To find the product, please multiply the numerators together and your denominators together. And you only need to multiply this 52 times 52 once because all the denominators will be 2704. And remember that we are not reducing any probabilities. Next, the probability of drawing 2 kings. Well, there are 4 kings in the deck. If we draw a king and then put it back, there are still 4 kings in the deck. So 4 times 4 is 16. 52 times 52 is 2704. Next, drawing a 6 and then a 7. So this is still an intersection, still going to multiply. So there are how many possible outcomes where we can draw a 6? 4. There are how many outcomes where we can draw a 7? A 4. 4 times 4 is 16. 52 times 52 is 2704. Now, for D through F, we are not replacing the card. So how does that impact our outcomes? It means the outcome of the second draw is dependent on the outcome of the first draw, so these are dependent events. We're still going to multiply because we have multiple events. But what changes is the first time you draw, there are 52 cards. The second time you draw, there are 51. So make sure you're accounting for that in your probabilities. So, what is the probability of drawing a red? 26. What is the probability of drawing a 4? There are 4 4s in the deck. Type in 26 times 4 in your calculator and you get 104 out of 2652. How many are black? 26. If I draw a black card the first time, now there are only 25 black cards. So multiply these together. 26 times 25 is 650. 52 times 51 again is 2652. Next, the probability of an ace and a face card. The probability of an ace is 4 out of 52. The probability of a face card is 12 out of 51. So now I'm going to have 48 out of 2652. All right, to wrap this up, we're going to end with number set theory. It says using the domain from 0 to 20. This is very important. We're going to let A equal all odd numbers. So come over here and write set A. Odd numbers start with the number 1. So 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. B are going to be all your multiples of 5. 5 times 0 is 0, so we have to start off with 0. 0, 5, 10, and 15, then 20. You are first asked to find A subtract B. So this means we're going to take all the odd and subtract out multiples of 5. So if I take my 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, if I take out any numbers that are multiples of 5, whatever remains is my answer. So 1, 7, 9, 11, 13, 17, and 19. What's that? Oh, I apologize. Thank you. 1, 3. Thank you. Next, B and N. This is an intersection. It's what they have in common. So simply look at B and A and see what they have in common. They have, these are odd numbers that are multiples of 5. So which numbers are odd and multiples of 5? Those numbers are 5 and 15. Next, you are to take set C and subtract out the union of A and B. Remember that the union of A and B is all of A and B together, including what they have in common. So that means I'm going to take my set C and I'm going to take out all odds and all multiples of 5. So I'm going to look up here at set C. 0 is a multiple of 5. 3 is odd. 9 is odd. And 15 is a multiple of 5. So what is left? 6 and 12. Last one, using the domain from 0 to 10. So we have less numbers we're working with. Set A will be all even numbers. So 0, 2, 4, 6, 8, or 10. Set B is going to be all multiples of 3 from 0 to 10. So only 3, 6, and 9. If I have to find the intersection of A and B and C, it is what A and B and C have in common. So let's take a look. Which numbers are even and multiples of 3 and in set C? So I'm going to look in set C and pick out all the ones that are even multiples of 3. And that would be 6 and 12. Oh, and yeah, and actually 0, because 0 is an even number. 0, 6, and 12. Next, I'm going to take set C and subtract out all the even. So C minus evens. So if I come over here and take out all the even numbers, 0 is even, 4 is even, 6 is even, 9 is not even, 12 is even, 14 is even, and 19 is not even. Lastly, I'm going to take set C. Hello? No, this is Ms. Robinson. Yes, I'm just recording a video right now, but yes, ma'am? I will. You're welcome. All right, next we're going to take set C, and we're going to take out all of A and B. So that means if it is even, we're going to take it out. If it is a multiple of 3, we are going to take it out. So look at set C here. I'm taking out all the even numbers and anything that is a multiple of 3. And what is left? 19. And that concludes your test review.